only have like 5 minutes because I did this whole video once and I realized I was making it harder than it was. So hopefully I do it the easy way and it goes by quick. At a nearby college, there is a school-sponsored website that matches people looking for roommates. So according to the reports, 42% of the students will find a match their first time using the site. A writer for the newspaper tests the claim by choosing a random sample of 170 who visited the site for a roommate. Of the students surveyed, 86% of them found their match for the first time using the website. So complete the parts below to the former hypothesis test to see if there is enough evidence at the 0.05 level significance to reject the claim that the proportion of all students who will find a match in the first time is using 42%. All right, so you have the null hypothesis is kind of the number that you're arguing about, which is 42%. So they say all students is 42%. I say it's something different than that. Oops, I forgot to put the P equals. P equals. So they said the proportion is 42%. And the school newspaper says, no, we're going to go do a sample. We can't ask everybody, so we'll ask 170 people, and let's see how close that is to 42%. If it's close, then we'll be like, okay, the newspaper's probably correct that it's 42%. If it's not, then we may be able to argue with them. So this says it's something different, so I just do P is not equal to 0.42. 42. Part B, you are just testing whether it is, we got good enough numbers to test. So my N is how many people are we going to go do a sample. We're doing a sample of 170, and you do it times P, so 0.42. This number has to be greater than or equal to 10 to have good enough numbers. Most of the time, it's always going to be, so you don't have to worry about it too much. But you got to answer these questions. So N is 170, and I'm going to take that times 1 minus P. I took the times P, now I got to do 1 minus P. Let me talk about 1 minus P for a second. If 42% of these people did use this website, how many didn't use? That's what 1 minus P is. So it'd be 0.58, okay? It would be 0.58. So anytime you see P, that's how many people said yes. Anytime you see 1 minus P, that'd be how many said no. So I just do 58% for that. So that is my 1 minus P times N is 170, 98.6. That goes here. Now I say that about the 1 minus P because we're going to use that in just a second. Let me get these numbers real quick before 86, 170. I don't even need them now. I made this so much harder just a second ago. I worked on this video for like 15 minutes. All right. These are newer topics in ALEKS, so I haven't gotten 100% used to them. P hat is, no, I just forgot. I was talking about something else. 170 and 86. 86 divided by 170 is our P hat. When we did our proportion, what did we actually get? So again, the newspaper is saying, what, 42%. And we went and did our sample, and we actually got 0.50588. Okay? We got 50%, which is 50%. So what this is saying, what this whole thing is saying is, okay, if we were to do this, we are looking kind of in the confidence interval range, and we're saying, okay, if I go do this sample, what's the chances that I fall in here? What are the chances that I fall in this range? Or what are the chances that I fall outside? And it's testing to see which one are we more likely to do based on that 95%. So what they have here, I shouldn't have erased all that. Which one is more likely to fall in the outside? So what they have here is what they call the test statistics. So you have these, this is called the critical region, and this is, these Z-scores are based on your confidence level. You don't have to know all this, but these Z-scores are based on your confidence level, and it's like, are we going to fall in here? So we're going to find what they call the test statistic and see where it would fall on this graph. So for 90%, we're trying to fall in this green area right here. So to do this problem right here, I have P, which is what the number we're arguing about. We already talked about 1 minus P. 1 minus 0.42 would be 0.58. So we have P and 1 minus P. We have P hat, talked about that. N is how many total people did we ask, which is 170. Okay, so that's all the numbers we need for that formula. Again, the idea here is the website said it was 42%. We did a sample and got 50%. So is that far enough away to say that if we did go ask everybody, the newspaper's wrong about their 42%? So now let's plug that in. So we get 0.50588 minus 0.42 divided by the square root of P times 1 minus P divided by N. Okay, so let me go to my phone calculator and do this so I don't have to go back to Alex real quick. On the top, I get 0.08588. That's how far away they were from the 42%. On the bottom, I do 0.42 times 0.58. 0.2436 divided by 170. Oh my goodness. Divided by 170 is a very small number. I would recommend doing this in the calculator on Alex. It's like 0.0014329, but then I do the square root of that number, and I get 0.03785. Yeah, I just don't like to do this because it's just too many decimals. Too easy to mess something up. So 0.8588 divided by 0.03785. I got 22. That's wrong. No way. So y'all get some first-hand mistakes here. I got an email about someone messing this up too. Very, very easy to mess those up. So let's go over here and just check this. So my P, again, was 86 divided by 170. So I'm going to do 86 divided by 170. I'll show you how to do this in the calculator. Now I'm going to, that's my P hat, minus my P, which is 0.42. That's the numerator, okay? Now if I take that number and I divide it by the square root of 0.42 times 0.58 divided by, whoops. How do I do this? If you highlight these, well, you can put them in parentheses, I guess, and then do divided by. Divided by 170. Let's see what I get. Oh, I bet I did. Okay. It's easy to make a mistake right there when you're just going fast. I must have done divide by 17 instead of 170. Because I got 24.6 but I would highly recommend using the calculator. You're less likely to make mistakes there. This was a two-tailed test. I didn't talk very much about that. I forgot. But since this is different than, we're just looking for a number that's different than, it could be less than that number or it could be greater than that number. You could be either one. If you read the problem, it's got to be less than, then you do this side. If it's got to be greater than, you do this side. I don't even know if I talked about that as much as I should have, but when you do this, the first person is always going to say equal. The null hypothesis is always going to be equal. You read the problem to see what the next person is going to say. They could say less than, they could say greater than, they could say not equal to. So if it's a if it's less than or greater than, that would just be one direction, left or right. Whereas if it's a two-tail, it's the different than. So now we got to paint which way we're doing here. Is it going to let me? There, it did it. And then it says enter the p-value. To find the p-value here, hopefully you remember this from chapter 7. I'm going to go by it quick. If not, go back and watch one of those videos. But the easy way to do this is I do p of 2.2688. That goes to the left of the positive one, and I subtract the negative one. That should give me that number, 0.9767. That's too big of a number. What did I do wrong? P is less than. Actually, you don't have to do all that, really. I'll show you another easy way to do it. Can't I just do P is less than... hit the right button. Negative 2.2688. And then take that times 2 because you got one on each side. Okay, so I found the left tail, and then I just multiplied it by 2 to get the right tail. So I must have put something in wrong on the calculator on that other one. All right, so my p-value is 0.02, which is, then you go to your level of significance, which is 0.05. So the p-value is less than the level of significance. So since the p-value is less than, the null hypothesis is rejected, and there is evidence to support that it's going to be something different than the 42%. I'm trying to click check to see it. All right, good. We